Why can people go to the moon but not further? This is the question that many of us have asked ourselves. After watching those amazing space documentaries, or after seeing a rocket launch in person, the awe-inspiring spectacle of a rocket taking off and the incredible journey it undertakes to reach the moon has captivated humanity for decades. But have you ever stopped to wonder why we can send rockets to the moon but not beyond? What are the challenges and limitations that prevent us from exploring even further into the vastness of space? Hello, and welcome back to our channel where we bring you the most intriguing questions from all over the world. Today, we're going to be diving deep into the topic of rockets and their ability to travel beyond our planet. Specifically, we'll be discussing why we can send rockets to the moon, but not further. It is a question that has both scientific and philosophical implications, and one that has kept scientists and space enthusiasts alike up at night. So buckle up and join us as we embark on a journey to uncover the secrets of the universe and the limits of human exploration. Now let's get started with today's big question. Why can people go to the moon but not further? To understand why rockets can reach the moon but not farther, it's important to first grasp the concept of gravity. Gravity is a force that pulls objects towards each other. The strength of this force depends on the mass of the objects and the distance between them. The closer the objects are, the stronger the force of gravity between them. This is why we stay firmly planted on the ground. The Earth's gravity keeps us from floating away into outer space. But what happens when an object ventures too far away from the Earth? As a rocket ascends higher and higher, the Earth's gravitational pull becomes weaker. At some point, the rocket will reach a region known as space, where the gravitational pull of the Earth is so weak that it can no longer keep the rocket in its atmosphere. This is the point at which the rocket is free to continue its journey into deep space. However, getting to space is only half the battle. To reach the moon, a rocket must overcome not just the Earth's gravity, but also the gravitational pull of other celestial bodies, including the moon itself. As the rocket approaches the moon, its gravitational pull becomes stronger and stronger until eventually the rocket is captured by the moon's gravity and begins to fall towards its surface. This is what allows the rocket to land on the moon. In essence, the moon's gravity does the work of slowing the rocket down and bringing it to a stop on the lunar surface. To make matters worse, there isn't just one force that pulls the rocket back to Earth. There are actually two. As the rocket leaves the Earth, it's propelled forward by the sun's energy. As it travels through space, it constantly accelerates away from the Earth. However, once it passes the moon, the gravitational pull of the Earth starts to take hold once again, slowing the rocket down as it heads back towards our planet. So why can't we make rockets that are powerful enough to overcome these forces and travel even further into space? One of the biggest challenges associated with launching a rocket is the sheer amount of energy required to lift it off the ground. Rockets are designed to carry their fuel, which is needed to propel them forward, along with the payload, which can include instruments, satellites, or even astronauts. As the rocket ascends, the weight of the fuel decreases due to the weakening gravitational pull of the Earth. However, the weight of the payload remains constant. This means that as the rocket reaches higher altitudes, the proportion of the rocket's total weight that is made up of payload increases, making it more difficult to lift off the ground. It's like trying to lift a box full of books off the floor. If the box is only half full, it's relatively easy to lift. But as more books are added to the box, it becomes increasingly difficult until eventually you can't lift it at all. To overcome this challenge, engineers have developed advanced propulsion systems that allow rockets to generate enough thrust to lift heavy payloads into space. However, these systems require massive amounts of energy to operate, which is typically provided by burning fuel. But there is only so much fuel that can be carried by a rocket before it becomes too heavy to take off. Another challenge associated with launching a rocket is the aerodynamic forces that the rocket experiences as it ascends through the atmosphere. As the rocket accelerates, it encounters air molecules that collide with its surface, creating drag and heating the rocket. To overcome these forces, rockets are designed with streamlined bodies that minimize air resistance. Additionally, the rocket's engines are shielded to protect them from the intense heat generated during launch. These engineering solutions allow rockets to withstand the extreme conditions of launch and reach high enough speeds to break through the atmosphere and enter space. However, these measures come at a cost. both in terms of the rocket's weight and complexity. As mentioned earlier, the weight of the rocket is a critical consideration, as it directly affects the amount of fuel that can be carried. The need for shielding and other protective measures adds to the overall weight of the rocket, making it more difficult to launch. Moreover, the complex systems required to control the rocket's trajectory and ensure its stability add to the cost and complexity of the launch. These factors highlight the immense engineering challenges associated with launching a rocket. While significant progress has been made in developing efficient and reliable rockets, the quest to explore the farthest reaches of space will require continued innovation and investment in research and development. So while we may have mastered the art of sending rockets to the moon, the challenges associated with launching rockets will continue to push the boundaries of our technological capabilities as we strive to explore even further into the unknown. Now let's talk about the speed of rockets. To achieve the incredible speeds required for space travel, rockets must undergo a process known as acceleration. This involves increasing the rocket's velocity over time to reach the necessary speed for launch. The rate at which the rocket accelerates is known as the acceleration rate. The higher the acceleration rate, the faster the rocket can reach its desired speed. Rockets typically use powerful engines to generate thrust, which is the force that propels the rocket forward. The amount of thrust produced by the engines determines the rocket's acceleration rate. To achieve the high acceleration rates required for space travel, rockets must carry massive amounts of fuel to power their engines. However, carrying large amounts of fuel adds significant weight to the rocket, which can offset the benefits of a high acceleration rate. Additionally, the engines themselves must be able to withstand the extreme temperatures and pressures generated during launch. The issue of rocket speed is further complicated by the fact that rockets do travel in a vacuum. They must navigate through the Earth's atmosphere, which creates air resistance and slows the rocket down. To overcome this resistance, rockets are designed with streamlined bodies that minimize air friction. Additionally, rockets must be carefully launched to avoid atmospheric drag as much as possible. These factors highlight the complexity of achieving high speeds with rockets and the delicate balance that must be struck between acceleration rate, fuel consumption, and atmospheric drag. In conclusion, the ability of rockets to reach the moon is a remarkable feat of engineering and scientific achievement. However, the challenges associated with launching rockets, including the need for massive amounts of fuel, the aerodynamic forces that slow them down, and the extreme conditions of launch, make it difficult to send them further into space. While we have yet to venture beyond the moon, the quest to explore the farthest reaches of space will continue to drive innovation and push the boundaries of human exploration. Who knows what the future may hold? With continued advancements in technology, we may one day be able to launch rockets at even greater speeds and explore destinations that are currently out of reach. Thank you for joining us today as we explored the fascinating topic of rockets and their ability to travel beyond our planet. We hope that you learned something new and gained a deeper appreciation for the incredible feats of engineering and science that make space exploration possible. Please don't forget to share your thoughts and comments below. We love hearing from you, and your feedback helps us to improve our videos and bring you the most engaging and informative content possible. And if you haven't already done so, please consider subscribing to our channel. We would love to have you join our community of curious learners, and we promise to keep you entertained and informed with our latest videos. Until next time, keep asking questions, keep exploring, and keep learning. The universe is full of wonders, and we're so glad that you're here to discover them with us.